Okay, good afternoon. Welcome to
Family Math number 14.
Family Math number 14. Today we're going to study a really neat thing that's part of a broader subject in math called number theory. And what do you think people study when they study number theory?
Numbers.
They study numbers, yeah, and they look for fun little relationships between numbers. And a lot of times it's with integers. And integers are just the things we count with, right? Like 1, 2, 3, 4, 5, or like -7 or -21, or what's another integer?
10.
10, yeah, good. Okay. So today we're going to look at a relation with cubes of integers. So I have to explain what cubes mean. So what does 4 cubed mean? Does anybody know? Yeah? What does 4 cubed mean?
4 times 4 times 4.
4 times 4 times 4. And that happens to equal what?
It's 16 times 4, which is 64.
That happens to equal 64, right? And like, let's do another one. 10 cubed. What does 10 cubed mean?
It means 10 times 10 times 10.
It means 10 times 10 times 10. I'm barely on screen here. 10 times 10 times 10. And what is 10 times 10 times 10?
1,000.
1,000. Okay. So we're going to look at a really fun relationship with numbers. And this is just for fun. It's just to show you some really neat things with numbers. And a lot of people study this, including some of the most famous mathematicians of all time study this. In fact, there was one really famous Indian mathematician named Ramanujan who studied this. And some people think he's the greatest number theorist ever. Okay, so we're going to look at a fun little pattern. So first of all, what is 1 cubed? 1 cubed is just
1 times 1 times 1.
1 times 1 times 1, which is just
1.
1. Okay, what is 2 cubed?
2 times 2 times 2, which is 8.
2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which
happens to equal 27.
Which happens to equal 27. And we already said that 4 cubed is 4 times 4 times 4, which is 64. Well, 1 cubed is 1. 1 cubed plus 2 cubed is 9. So I'm just going to sum them down the column here. 1 plus 8 is 9. What's 1 plus 8 plus 27? That's the same as 9 plus 27. And what is 27 plus 9?
30.
30 what? 30 what? 27 plus 9 is?
36.
36, very good. 36. And what is, if I go 1 plus 8 plus 27 plus 64, that's the same as 36 plus 64, and what's that?
It's 100.
That's 100.
Interesting.
Oops, not 1,000, 100. Okay, so do these numbers look familiar? 1, 9, 36, 100, do they have any special properties? Do those look like they're part of anything special you know about the number 100, for example? 100 is?
Well, it's 10 squared.
It's 10 times 10.
Oh,
what is 36?
It's 6 squared.
6 times 6. What is 9?
It's 3 squared.
And what is 1?
That's 1 squared.
1 squared, okay. So we just ran across a really interesting property here. That 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. I'm going to do it up to 4, but the same property held. And remember, this is 100, which is 10 squared, which happens to equal 1 plus 2 plus 3 plus 4 squared. In other words, 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed, which was 100, is the same as 1 plus 2 plus 3 plus 4 squared. And it turns out that this is true for any numbers, any integer, if you start at 1 and count up to that number. Okay? So in other words, if I did 1 cubed plus 2 cubed plus 3 cubed plus up to 10 cubed, this would equal 1 plus 2 plus 3 plus up to 10 squared. Okay? So that's pretty amazing. So the question is this unusual? Do you find situations where cubes add up to squares? Okay? And there was a French mathematician named Joseph Liouville who studied this. And he lived in the 1800s. So his name was Joseph Liouville, and he lived from 1809 to 1882. That was a really long time ago, right?
Mm. Yeah.
Super long time ago. That was before they had computers, or TV, or Legos.
We had no TV.
Or...
iPad.
They definitely didn't have iPads back in 1809. Can you believe that? What do you think they did all day without iPads?
I don't know.
I don't know either.
Probably just ran.
Probably just ran around. Maybe they just studied a lot of numbers. So Joseph Liouville came up with an incredible formula. He said if you take a number, let's take the number 10, okay? And you look at the divisors of 10. And divisors are numbers that divide into 10. So for example, the numbers that divide into 10 are 1, because 10 is 10 times 1. What's another number that goes into 10? Okay, go ahead.
2.
2 works.
5.
5, no, okay, wait, now, there's one more number that divides into 10. Can you figure it out? What number goes into 10? Sit up straight. What, 2 times 5 equals 10. 1 times what equals 10?
1
times 10. 1 times 10 equals 10. So these are the 4 numbers that divide into 10. And you look at the divisors of these numbers. So there's only one number that divides into 1. How many numbers divide into 2?
2 numbers?
Yeah, 1 and 2 divide into 2. So there's 2 numbers that divide into 2. What numbers divide into 5?
Only 2 numbers.
1 and 5, right?
These...
So that's 2 numbers. Now, here's the thing. How many numbers divide into 10? We wrote them down, right?
4 numbers.
So 4 numbers divide into 10. Okay? Now what we're going to do is we're going to take a look at 1 cubed plus 2 cubed plus 2 cubed plus 4 cubed. Okay? This is 1. Do you remember what 2 cubed was? It's 2 times 2 times 2, which
8.
is... Oh, shoot, my thing got shifted up. What is 2 cubed?
8.
2 times 2 times 2 is 8. Plus 8. And then do you remember what 4 cubed was?
64.
64. Okay. And so what is 1 plus 8?
1 plus 8 is 9.
Plus 8 is?
8.
9 plus 8 is?
7. 9 plus 8 is 17.
17. And 17 plus 64 is?
Is 81.
81.
Is
81 a square?
Yeah, it's 9 squared.
Okay. It happens to equal 1 plus 2 plus 2 plus 4 squared, because 1 plus 2 plus 2 plus 4 is?
1 plus 2 plus 2 plus 4
is? Oh, 1 plus 2 is?
3.
Plus 2 is?
5.
Plus 4 is?
9.
9. How about that? Now, isn't that amazing? So we just made another sequence of numbers so that the sum of their cubes was equal to the square of their sum. Now we're going to do it one last time, and this is what this guy Liouville proved. Okay, now let me scoot down so that I'm... Now we're going to look at it with the number 20. Okay, now 20 is a little harder to figure out what numbers divide into 20. But 1 goes into 20, definitely. Mm-hmm. Can you tell me another number that goes into 20?
Mm-hmm.
What do you think?
2.
2. 2 times what equals 20?
2 times 10.
2 times 10 equals 20. And here's the rest of the numbers that go into 20. 4. 4 times what equals 20? Do you know?
5.
5. Okay. 2 times what equals 20?
10.
10. And 1
20.
times what equals 20? 20. Okay, now we're going to look at the number of divisors. 1 has 1 divisor. 2 has 2 divisors. 4 is a little tricky. How many divisors does 4 have? What numbers go into 4?
Well, there's 3 divisors.
Because 1, 2, and 4. That has 3 divisors. 5 has how many divisors? 2. 10 has how many divisors? Do you remember? We just did it. 4. And 20 has 6 divisors because we actually just wrote them down. 1, 2, 3, 4, 5, 6. Okay, so now we're going to look at this crazy sum. 1 cubed plus 2 cubed plus 3 cubed plus 2 cubed plus 4 cubed plus 6 cubed. Okay? This happens to be 1 plus 8 plus 27 plus 8 plus 64. And anyone know what 16 cubed or 6 cubed is? I mean, it's 6 times 6 times 6, which is 36 times 6, which is 216.
Oh yeah.
Yeah. And this whole thing adds up to 324.
Wow.
Okay? So that adds up to 324, but it turns out that 324 is something squared.
Wonder what?
It's 18 squared. And what is 1 plus 2 plus 3 plus 2 plus 4 plus 6? Well, 1 plus 2 is?
3.
Plus 3 is?
6.
Plus 2 is? 6 plus 2 is? 8. 8 plus 4 is?
Or 12.
And 12 plus 6 is?
12 plus 6 is 20.
12 plus 6 is?
12 plus 6 is 20.
No, 12 plus 6.
22.
12 plus 6. You know what 12 plus 6 is.
18.
18. Very good. So again, the sum of the cubes is equal to the square of the sum. That is amazing. So you have these really pretty relationships between numbers that people have studied over time, and people are still discovering them today. Isn't that amazing?
Cool.
Who would have ever thought you could find all these really neat things about numbers?
Whoa.
It's really fun stuff. You guys excited about this?
Yeah.
All right, good job today, guys.